we're going to talk about the law of syllogism and the law of detachment. But before we start, I want to look at this orange sticky note real quick. Just to review, P arrow Q means if P then Q. It's a conditional statement. It's also the same thing as saying P implies Q. So, if one, then the other one. Okay? So let's go through these two laws. The first one we're going to talk about is the law of detachment, which says if you are given a conditional statement that is true and a hypothesis of the conditional statement that is true, then the conclusion is also true. Okay? So just let's think about this. What this is saying is if you have P then Q, if you have this and this is true and the hypothesis is true and the whole thing is true, then you can conclude that the conclusion has to also be true. Okay, so if P then Q. Alright, so if P then Q is true and you are given that P is true, so we know that this is true, then Q is true. That's what we can conclude. True. They're both true. The law of syllogism, which is also called the transitive property for conditionals, says that if you have two conditionals that are both true, okay, where the conclusion, or rather the Q, of the first is the hypothesis of the second, then you can conclude that the first hypothesis implies the second conclusion. Okay, so another way of saying this, just like with the transitive property for expressions in algebra, if we said, A equals B, so if A equals B and B equals C, then A equals C, we can use the transitive property across those two B's to say that A equals C, right? That's what the transitive property in algebra said, so we're going to use this for syllogism. We are going to use this in geometry. So if P then Q, if P implies Q and Q implies R, then P implies R, because again we're doing the same thing. We're overlapping by the Q, and so then that allows us to just jump from P straight to R, okay, because the Q's match up. Okay, so if P then Q is true and if Q then R is true, are both true, then we can chop out the middleman, jump straight to the last conclusion and say then P implies R. P implies R. Okay? Here are some examples. If an angle is obtuse, then it cannot be acute. Well, that's obvious. So this is obviously true. Okay, given. Angle A is obtuse. Well, if angle A is obtuse, then it cannot be acute, based on this statement right here. So our conjecture is that angle A cannot be acute. You see how I did that? Angle A is obtuse, then it cannot be acute. Which law did we use for this? We used detachment. Okay? Oh, another trick here, if you're trying to figure out which one to use, for syllogism you have to have two different conditionals to start with. You have to have two of them, because you have to go trans across two different things. Okay? Here's another one. If I pass the test, then I will get an A in geometry. Okay, the given is I passed the test, so our conjecture is that I got an A in geometry. Which law did I use? I used detachment. Okay. Okay, if the electricity is out, then the refrigerator won't work. If the refrigerator won't work, then the food will spoil. Okay? So the given is the electricity is out. Well, if the electricity is out, then the refrigerator won't work, which means the food will spoil. So if the electricity is out, we can jump straight down here and say the food is going to spoil. So the food will spoil, and that was syllogism.